Hi everybody, this is Brendan with Common Motor, common-motor.com on the internet, and in today's video we're jumping back into our electrical diagnostic series. On this particular bike we're doing a Honda 360 and we're looking at the starter solenoid circuit for bikes that are equipped with the safety switches. And what that means is in '74 Honda started adding safety switches to the bikes so you were not able to start the bike with the electric starter in gear. That was a mouthful. We'll dive in and show you all the bits and pieces here in just a minute. Stay tuned. So back in 1973, the US government updates a bunch of the safety standards on vehicles across the board. Motorcycles were no exception. So in 1974, a bunch of updates had to happen to comply with these standards. For the motorcycles, at least with these old Hondas like this 360, part of them had to do with the electric starter system. Prior to then, you were able to actually have the bike in gear, hit the electric start button, and turn the engine over. What that would mean though, if you didn't have the clutch squeeze, was the bike would lunge forward, which really isn't safe. So on this revised safety system with the electric starter, the starter system, or starter solenoid system, you have to either squeeze the clutch or have the bike in neutral for the electric starter to turn. That way you couldn't have this like a lunging type phenomena happen on the bike. Of course, with that means there's more circuits and more switches in the system to try to diagnose when troubleshooting if any of the parts are working or not. To make matters even more complicated, there's a early version of the safety switch solenoid start system and a later version of the safety switch solenoid start system that showed up on the bikes. So in '74 and '75, we get the very first version of this system. We're going to be going over it in detail on this 360. Starting in 1976, some of the other bikes had a amended version of the system that has a different wiring structure to it and has a couple extra pieces factored into the game. Additionally, we have some other bikes, some of the 550s and 750s in the early 70s that had their own unique little control box for this. On the wiring diagram it says safety switch control box, this little gray box in the picture. By the late 70s, Honda got away from that and kind of wired it up differently. So there's lots of different kind of subversions of these safety switches, or safety systems, I should say, in the wiring. And we're not able to cover all of them in this video, but we do have a very detailed article that accompanies this that goes into the variants of the system, so you can kind of figure out which one you might have to deal with. But we can quickly identify the two different versions of these starter systems fairly easily. Basically, if your bike was built from 1976 forward, it probably has the late style system. This is identified by if you push the start button on the bike and the headlight turns off, then you have the late style system. If that doesn't happen, then you have the early style system that's usually going to be on bikes built in '74 and '75. Also, later style bikes or later style systems don't usually have a headlight on-off switch. If the key is on, the headlight's on. Earlier bikes will still have a headlight on and off version most of the time. There are a couple of sub-variants of that and some exceptions. Those details are in the article below, so make sure you look at the article if you're not sure on which one you have. We're going to now actually show you the path routing and the electrical routing for this early style safety switch version of the solenoid. As with many circuits, and almost all circuits, we're going to start with ground, which we know is the negative terminal of the battery, aka everything that is metal on the bike. If you have not watched our video on understanding ground circuits, you make sure you watch that first, because otherwise it's hard to comprehend. Now, this circuit has two different places the ground starts from. The first place is going to be routed through the ground through a switch that's right here on the clutch lever. We have a wire here, and it travels from a green wire into this switch, and now a green wire and red wire. That is ground point number one. And by the way, this switch is the same switch that shows up on many of the other Hondas as a brake light switch on this side, common motor part 1038. So our second ground actually starts with the neutral light switch, which actually is connected to the body. It goes through the neutral light switch, through a light green and red wire up to this little thing right here by the ignition coil. This is a diode. It's a one-way door. And once it passes through the diode, that wire color changes from light green and red to dark green and red. The purpose of the diode is to keep ground connection from happening in the circuit if you squeeze the lever, which would trigger the neutral light to turn on. Because we want the neutral light to turn on if you're in neutral, but not when you squeeze the lever. That's kind of the reason this diode is in here. So we're gonna go from the diode or from the handlebar switch up to the actual push button on the right side control here. So that's gonna be the dark green and red wire. From the button here, that makes contact with the yellow and red wire, which runs all the way back to the actual starter solenoid, which is here, right behind the battery. From the starter solenoid, it runs through it and back out to a solid black wire, which we know is 12 volt positive with the key on. If you've not watched our video on understanding the 12 volt positive side of the circuit, you gotta watch that video as well to understand there. But that is the basic layout of the activation circuit for the starter solenoid. The other part of the solenoid is that a solenoid is just a switch that triggers a switch. And the solenoid is what connects the battery to the electric starter. So just because the solenoid activates doesn't mean that the contacts, which are the big wires from the battery down to the starter, are making contact, and those are at the big terminals here. So not only are we going to check that the subsystem is activating the solenoid, we will check that the actual solenoid itself is bridging these two main terminals together so the starter turns over. Gone ahead and taken off the headlight, and we're in the headlight bucket with the bird's nest. And what we're looking for is we have a switch here on the handlebar on the clutch side that runs into the bucket here, and here's our switch wire here. I'm kind of pulling on it, and we're going to test this switch to make sure it's working. I mentioned earlier that this is the same switch that's used on the brake light circuits, and I can actually see on this particular bike, someone has actually changed this switch out because the wire colors are slightly different. It still works the same way. The original switch would have been a green wire and with a green, and the other one was a green wire with a red stripe. This happens to be a green with yellow wire and a black one. Color code doesn't really matter because it's just an on-off switch. So I'm going to go ahead and unplug this black wire here, and the black wire is plugged into that original green-red wire here. Our other switch, side of the switch, is connected to ground. We've verified ground, and we're going to test to see if this actual switch is working when we squeeze the clutch. And we're going to do that using our test lights. I always test the test light to make sure it's working, so I'm going to connect to ground here, which is always a dark green wire. I'm going to turn on the key switch. Come on. Oh, wait. Oh man, my hand doesn't turn that way. There we go. Key switch. Our running lights are on. And I also have a bundle here of solid black wires, and we know that solid black wires are 12 volt positive back to the battery. If you haven't watched that video on 12 volt positive circuit, make sure you do that. And therefore I have power from solid black. I got a good ground connection. Okay. So what I'm going to do now is I'm going to connect my test light to the actual wire that went to the switch. And then I'm going to connect this end of the test light to my 12 volt positive. And I should squeeze the lever and the light should kick on. So this clutch lever safety switch is properly working. The next piece we're going to look at in this safety switch system is actually this little piece right here next to the ignition coil. A lot of people don't know what this is, but this is a diode. I'll take it off of here. And coming off of this diode here, I have a dark green and red wire, which we talked about. That's what ends up going back up to the switch here. And I have a light green and red wire that goes back to the neutral switch on the bike. And what a diode is a one-way door. So we're going to test the circuit back to the neutral switch, and we'll actually test the diode itself to make sure it's working. We'll slide it out of there, put it aside. And I'm going to take my test light. I'm going to connect my alligator clip to the positive side of the battery. Therefore, I should have good connection to the battery. Let me just check here and ground. All right, so I have good connection to the ground. And I'm going to tap this into the light green and red wire here on the terminal. Light kicks on. That says I have connection from here all the way down through the neutral switch to ground. And if I shift the bike out of gear, this light should kick off. Our neutral switch is working correctly, and that means we have ground connection from the switch up to this point. Now, if this is not working correctly, we do have a video going over how to diagnose the neutral switch on all the different bikes. So make sure you check out that video as well. So we know this side is going to get ground good, other switch is good. Let's actually test the diode itself to make sure the diode is working. I still have my test light hooked up to the positive side of the battery. What I'm going to do here, my diode, is to test it. I should be able to hook it up one way, and the light turns on, and I hook it up the opposite way, the light should not work. So let's try it like this first. I'm going to connect this to ground up here. I'm going to touch my probe to this other connection here, terminal, and I have nothing. All right, that's fine. I'll take this and I'm going to reverse it. Connect my alligator clip to that side, and hopefully our test light should kick on. And sure enough, it does. So that says my diode is working because the current can only move through it one way. If you do this test and it doesn't light up at all, or if it lights up going both ways, it says that the diode is bad. It should only light up going one direction. All right, our next piece to test is we're going to test the actual start button switch here. And sometimes this bundle of wires is in the headlight bucket. On this 360, it happens to be under the tank here. That's why I have this other bird's nest open. And I've identified both our green and red wire and our yellow red wire. Now I got to figure out which half of these, which half goes to the switch and which half goes down to the solenoid. So what I'm going to do is I'm going to unplug them. I guess I'll unplug these two, right, from here. And I'm going to figure out between the green reds, if it's this one or this one that connects to ground, because we've already tested the fact that our ground connections work through both the handlebar switch and the neutral light switch. So I'll take my test light, I'm going to hook to the positive side of the battery here. Always test it on the ground, so my test light is working good. Let's go with this green and red wire here. If the test light kicks on, we're connected to ground, it doesn't kick on, so that's the one that goes to the switch. That means the opposite side here should kick on. Sure enough, it does. And I can verify that by, I'm going to shift the bike out of neutral here, reach over. That turns off there. And I can also do that with the handlebar switch as well. See how that turns on, that reconnects it to ground, disconnected from ground, neutral, reconnect to ground. So that's that side. So now I can just test if the wires that go in and out of the switch are properly working. And a lot of times this is dirty or there's broken connections in here, and that's usually a problem with this. So let's test that next. In this case, I'm going to go ahead and I'm going to hook a jumper here. I'm just going to go to ground with my alligator clip. I could just touch it to the frame if I wanted to. My test light's still hooked to my 12 volt positive on the battery. Test light's still working. I'm going to touch it here to this terminal. A little bit easier. Just hold it there, my fingers. And I'm going to hit the start button and see if the light kicks on. Sure enough, it does. So, all right, my start button circuit in and out works fine. So we know that our starter button is good. All right, we're back here at our starter solenoid, which is right here. Here's my red and yellow wire that comes from the switch into the solenoid. Out of the solenoid is a black wire, which we all know should be 12 volt positive, key positive here. That looks like it's plugged in down there. So we're gonna be able to check the actual circuit going to the solenoid first before we even attempt to turn it on. Yeah, there it is. It's plugged into a solid black. I can see it under there. All right. We're going to do this in 2 quick steps. I'm going to unplug this. This one's going to the solenoid. This one's coming from the switch. Let's verify that we're getting power down there from the switch. Real easy. I'm going to connect my test light to 12 volt positive. As always, we're there. We're good to ground. And what I should be able to do is touch this to here. Hit my start button. Let me flip this around so you guys can see it better. Do that, hit my start button, and it works. So that means my wiring from the switch all the way back here to the solenoid is good with the start button and our ground circuit. All that stuff's good. Great. The next thing I'm gonna do is I'm gonna check to see if I have power going through the solenoid. We know that 12 volt, this black wire is 12 volt positive. So in this case, I'm gonna move my test light over to ground or negative, turn my key on, and I'm gonna see if I have power coming through this wire, because this goes black into the solenoid, out of the solenoid via the red yellow wire, and sure enough, I have power there. So that means that side of the circuit's good. Okay, therefore our solenoid should kick over, or at least activate, when I turn the key on. But we're also gonna check to see, are we getting power across these terminals internally? Because just because the solenoid clicks doesn't mean that it's connecting the high tension leads from the battery to the starters. So in order to test this, we're going to disconnect the starter from this side of the solenoid and use our test light as our load and see if that clicks and kicks the test light on at once. We're going to be testing if the solenoid engages and clicks, and then also if the test light will kick on as I go across the 2 terminals. This front terminal here is already connected to 12 volt positive. Therefore, I just need to connect my test light to ground so we can go to the negative side of the battery or anywhere that's ground, all right? I'm going to touch this terminal right here, large one on the solenoid. So we're going to see 2 things happen, or we're going to listen for a click, and we're also going to see if the test light kicks on when I activate the start button. So key is on, bike is in neutral, and let's hit the start button. There we go. Not only are we getting the light to kick on, but we're getting the click, which says that the solenoid is actually working. Okay, we got our bike back together, and we're gonna test out our circuit to make sure it's working properly. So key switch on. I got my neutral light on. That says my neutral light circuit is connected to ground. And I should be able to hit the start button and the electric starter should turn over. Let's see what happens. And it works. Now, if we tested everything and the starter didn't turn over when you hit the button, that means there is some kind of problem in between the solenoid and the starter itself. Maybe it's a bad wire, maybe the starter needs to be rebuilt, but at least we know up to the solenoid it's good. Now, because this was the safety circuit, we're gonna test the other elements of that. Because we were neutral before, we're neutral right now, I should say. Let's shift the bike in gear. Turn the wheel here, and there we are. First gear, our neutral light is off. This means I should not be able to turn the starter over when I hit the start button. So let's confirm that. And it's dead, as it should be. Luckily our bike's in the center stand. But if I squeeze the clutch, I'm gonna stay on this side. Now the starter should work because I'm engaging our safety switch here on the clutch, and see that move? It moves. But you should always start your bike in neutral regardless, so keep that in mind. But that's how that circuit is set up. All right, success on this bike. We tested each component out. Everything's working properly like it should. Great. I do want to make a last touch point on some of the bikes that use the slightly different later version safety circuit. Now, all these pieces that we showed here and tested here are in those circuits. Those bikes do have a clutch safety switch. They have the neutral safety switch. They have a diode. They all work on the same basic premise, and so the testing process of those pieces is going to be the same. Your major difference you're going to find is going to be the wiring for the actual push button in the right-hand switch. Again, you're going to refer to your service manuals and, of course, the article down below, which goes into more detail of that. As always, thank you for joining us. This has been Brendan with Common Motor, common-motor.com on the internets. Make sure you like and follow us on Facebook and Instagram. Subscribe to our newsletter through our website, and of course, subscribe to this YouTube channel down below. Ring the bell for notifications, and we'll see you next time.